The first molecular geometry is linear. It has two bonding areas, zero non-bonding areas. A specific molecule would be carbon dioxide. The electron domain geometry is linear, and the molecular geometry is linear. This molecular geometry is the trigonal planar. It has three bonding areas, zero non-bonding areas. A specific molecule that this would represent is boron trifluoride. The electron domain geometry is trigonal, along with the molecular geometry. The molecular geometry is bent or angular. It has two bonding areas, two non-bonding areas. A specific molecule would be H2O or water. The electron domain geometry would be tetrahedral, and the molecular geometry would be bent. The molecular geometry is tetrahedral. The number of bonding areas is 4. The non-bonding areas is 0. A specific molecule would be methane. The electron domain geometry is tetrahedral, along with the molecular geometry. The molecular geometry here is the trigonal pyramid. It has 3 bonding areas, 1 non-bending area. The specific molecule would be ammonia. The electron domain geometry would be tetrahedral, and the molecular geometry would be trigonal pyramid. This molecular geometry would once again be bent or angular. It has 2 bonding areas, 2 non-bonding areas. The specific module would be H2O. The electron domain geometry would be tetrahedral, and the molecular geometry would be bent. The molecular geometry here is the trigonal bipyramid. It has 5 bonding areas, 0 non-bonding areas. The specific molecule is phosphorus pentachloride. The electron domain geometry is trigonal bipyramidal, along with the molecular geometry. This molecular geometry here is the sawhorse or seesaw. It has 4 bonding areas, 1 non-bonding area. The specific module is phosphorus trifluoride. The electron domain geometry is trigonal bipyramidal, and the molecular geometry is the sawhorse. This molecular geometry is the T-shape. It has 3 bonding areas, 2 non-bonding areas. The specific module would be chloride trifluoride. The electron domain geometry would be trigonal bipyramidal, and the molecular geometry is the T-shape. The molecular geometry would once again be linear. It would have 2 bonding areas, 0 non-bonding areas. The specific module would be carbon dioxide. The electron domain geometry would be linear, along with the molecular geometry. The molecular geometry here is the octahedral. It has 6 bonding areas, 0 non-bonding areas. The specific molecule is sulfur hexafluoride. The electron domain geometry would be octahedral, and the same thing occurs with the molecular geometry. This molecular geometry is the square pyramid. It has 4 bonding areas, 1 non-bonding area. The specific module would be bromine pentafluoride. The electron domain geometry is trigonal bipyramidal, and the molecular geometry would be square pyramidal. The molecular geometry here is the square planar. It has 4 bonding areas, 1 non-bonding area. The specific module would be bromine pentafluoride. The electron domain geometry would be trigonal bipyramidal, and the molecular geometry would be square pyramid. Molecular geometry here would be T-shape. Once again, it has 3 bonding areas, 3 non-bonding areas. The specific module would be chlorine trifluoride. The electron domain geometry would be octahedral, and the molecular geometry would be T-shape. Last molecular geometry here would be linear, once again. It has 2 bonding areas, 4 non-bonding areas. The specific module would be xenon difluoride. The electron domain geometry would be octahedral, and and the molecular geometry would be linear.